This is an example of a simple monohybrid completely dominant trait. So here we're looking at Mr. and Mrs. Krabs, and we're looking at tall eyeballs. And the problem says that tall eyeballs are dominant and short eyeballs are recessive. And so here it says Mr. Krabs is homozygous for his tall eyeballs. So that means that if he's homozygous, it's the same. And since tall is dominant, means Mr. Krabs is going to be big T, big T. And since the male's gametes go on the left, that's big T, big T. Now, Mrs. Crab is heterozygous for her tall eyeballs because some members of her family have short eyes, and that's recessive. So she's going to be big T, little t. So what we want to know is possible genotype and phenotype for their children, and did the hospital make a mistake? So in our problem it says the baby had short eyeballs. So we're trying to figure out if that's possible. So one possibility is big T, that would be tall eyeballs. Another one is big T, that would also be tall eyeballs. Big T, again tall eyeballs. Big T, again tall eyeballs. So there is no possibility here that they could have a baby that has short eyeballs. They can have a big T genotype or a big T genotype, the heterozygote, but they cannot have little t, and that's the only thing that would give us short eyeballs. So apparently the hospital must have made a mistake. In this question, we need to see which one is possible. And so here we're looking at an example of polydactyly, and that is extra digits on your hands and feet. And that is a dominant trait. So we have a man that has 6 fingers and 6 toes, so we know that he's got the dominant trait, but he could either be, and let's stick with T's, he could be big T, or big T, right, and still have extra toes. The wife and his daughter have a normal number of digits, and since extra digits is dominant, we know that his wife must be little t, and he also must have a daughter that's little t. So what that tells us is if he's got a daughter that had little t, then he must be big T. So we want to know what fraction of the children would be expected to have extra digits. So dad is big T, mom is little t. We're going to get 2 that are heterozygotes. That's a big T there. And we're going to get 2 that are homozygous recessive. So that's going to tell us it's a 50% chance of being normal and a 50% chance of getting extra digits. So that's a 50% for that one.